Today's lesson is on solving inequalities using multiplication and division. There's an additional rule we must point out before we begin. Whenever you multiply or divide by a negative number, you must reverse the inequality sign. So let's take a look at the first example problem that has been done for you. What are the solutions of negative 6h less than or equal to negative 39? This is the original problem. We need to start by undoing this multiplication. Instead of multiplying by negative 6, we're going to do the inverse and divide by negative 6. As soon as you see that we are dividing by that negative number, we must follow the rule of reversing the inequality sign. So you can see that instead of less than or equal to, now it becomes greater than or equal to. So then go ahead and do the division. Negative 6 divided by negative 6 is 1h. You bring down that reversed inequality sign. Negative 39 divided by negative 6 is positive 6 1/2. And then you, of course, graph it like we did earlier in solving inequalities by adding and subtracting. 6 1/2 is in between 6 and 7. So you can see this solid circle because we do have a greater than or equal than sign. And our answer h is to the right of that. So let's go ahead and do some sample problems on our own. So in this first one, we have x divided by 7 is greater than negative 2. So to undo the division here, we're going to multiply the left side by positive 7, and we're going to multiply the right side by positive 7. Now when we decided to multiply by positive 7, that's not a negative number, so we leave the inequality exactly like it is. These 7's cancel and equal 1x is greater than negative 2 times positive 7 is a negative 14. And just like we did when we did the addition and subtraction problems, you do need to graph it. So always identify where 0 is and your answer, negative 14. Because it's a greater than symbol, we will leave an open circle there. X, our answer, is greater than negative 14. Numbers that are greater than negative 14 are to the right of that, so we want to bold to the right. In the second example, 8 times p, we will undo that by dividing both sides by 8. Since we are dividing by a positive number, we do not reverse the inequality sign. 32 divided by 8 is positive 4. Then you can go ahead and quickly make a graph. Always identify where 0 is and your number from above. Since it is less than or equal to, this is a solid circle. P, our answer, less than or equal to 4. Those numbers would lie to the left of 4. Moving on then to problem number 3, we have 2/5 r greater than or equal to 6. Remember, when your coefficient is a fraction, you are going to use the reciprocal of 2/5. The reciprocal just means to flip-flop the numerator and the denominator. The reciprocal of 2/5 is 5/2. So we're going to multiply the left side by 5/2. And we're going to also multiply the right side by 5/2. So it will look just like so. We can see that these guys cancel each other out because a reciprocal times the original number is always equal to 1. So there's our 1r greater than or equal to. Over here, you can multiply either straight across and then divide, or you can take advantage of those common factors. Either way, we would get 15 on the right side. So r is greater than or equal to 15. If you use the accompanying graph, always identify where 0 is. 15 is to the right of 0. Greater than or equal to, we need a solid circle, and those numbers are to the right of 15. In number 4, we have a negative k divided by 2. Now another way to actually write that would be, there's that imaginary 1 next to the k, and then you can have the k right here. So this is just another way to write it. I do think it's a little bit easier to understand when you write it this way, but know that k over 2, or negative k over 2, is the same as negative 1 k over 2. So if we find the reciprocal of negative 1/2, that is negative 2 over 1. So we're going to do that on both sides. Now in this example, we are multiplying by a negative number here. So when these guys all cancel out, we need to reverse this inequality sign. So we end up with k instead of less than, it becomes greater than. -5 times -2 is a positive 10. Then we're going to go ahead and graph, just like we always do. 0 is here, positive 10. Because it's a greater than symbol, it's an open circle. K is greater than 10, so those numbers lie to the right of 10. Moving on to 5 and 6, we have a -3 times f is less than or equal to 12. So we are going to divide by a -3 on both sides. So we do need to reverse the inequality. We get f is greater than or equal to 12 divided by -3 is -4. Once again, supplying the graph that would accompany the answer, we have 0 identified and -4. Now, because we have a greater than or equal to symbol, we need a solid circle at -4. Since f is greater than or equal to that, it would bold to the right. In example 6, we have 3/5 times t, so we need to find the reciprocal of 3/5, that is 5/3, and we are going to multiply by 5/3 on the left as well as the right side. Over here, these common factors, of course, cancel out, and we're left with our t here on the left side is greater than. Over here, don't forget that imaginary 1 is under that -9, so now you can see diagonally that they have a common factor of 3. -3 times 5 is -15. We never multiplied by a negative number here on both sides, so we did not reverse that inequality. To create your graph, we have 0 here and -15 over here to the left. It is an open circle. Since t, our answer, is greater than -15, those numbers would lie to the right of -15. Okay, last couple of examples. We're going to undo this multiplication. We are dividing both sides by a negative number, so that means we need to reverse the inequality. Instead of greater than, it becomes less than. -2 divided by -2 is a 1w. -8 divided by -2 is a positive 4. Again, creating your graph. Here is 0, positive 4 is this way. W is less than positive 4, and it is an open circle, so it is going to bold to the left. In example 8, here we have a variable in the numerator over 5, and it is a -z. So remember, another way to write that is just writing that invisible 1 right there, and I'm going to leave the z over here, greater than or equal to 4. Let's find the reciprocal of -1/5. That is -5/1. So you are multiplying both sides by a negative number. So that means we need to reverse this. Instead of greater than or equal to, it becomes less than or equal to. And again, finding those common factors leaves us with 1z. 4 times a -5 is a -20. Of course, we don't need that 1 in the denominator. And then we're going to go ahead and graph it. Here's 0. -20 is down here to the left. Since z, our answer, is less than or equal to that -20, we do need a solid circle, and it's going to bold to the left. Okay, that leaves us with only 2 more examples. Here's another one where we have a fraction as a coefficient. So again, finding that reciprocal of -3/4, that's -4/3, and you're going to be multiplying times a negative number. So you do need to reverse that inequality. So instead of less than, it is going to be greater than. And we are multiplying both sides by -4/3. So over here, these guys all cancel and leave us with the 1d is, oops, I accidentally wrote an equal sign. Let me change that quickly to a greater than symbol. And over here, we do have common factors, the 3's, and also the 4's. So we end up with a negative times a negative is a positive, and it is +2. So let me go ahead and circle that and provide a graph. So with this particular graph, we are going to have, oh, actually, this is 1/2. I'm sorry. -1 times -1 is 1, and then 2 times 1 is 2. So it's positive 1/2. So to create this graph, when you graph a fraction, you can actually put a 1 here. So we know that 1/2 is in between 0 and 1, so that would be right here. So I'm just going to go ahead and squeeze that in. It is an open circle, and D is greater than 1/2, so that moves to the right. In the last example, we are dividing both sides by a negative number. So we do need to reverse the greater than or equal to less than or equal to. 14 divided by -4 would be equal to -3 1/2. So again, to graph a mixed number, it works kind of the same way here. Here's 0. If you actually want to put in +4, you can, just to show that it's not quite at 4, or you can just put a -3 1/2, and it will be a solid circle, and the answer is less than or equal to that -3/2, so it does move left. And that wraps this up. Thank you.